You're now, I would claim, you're now awake, you're wide awake, and you can be aware of my face, of the fact what sort of, that I wear a colorful shirt, that I talk with this Schwarzenegger-like accent. And so this I would call an operationalized definition of consciousness.
Christophe, why have you and Francis Crick, who I guess is best known for discovering the structure of DNA, chosen visual awareness to study consciousness?
We believe that because consciousness is an evolved property, that probably nature discovered, it was discovered once during evolution, and the different forms of consciousness, i.e. visual consciousness, auditory consciousness, maybe even high-level self-consciousness, are probably just different variants of the same theme, the same mechanism.
So they've designed experiments to test visual consciousness. Eileen Wexler has normal vision, but this test simulates a phenomenon called unconscious vision, or blind sight, that can occur when there's damage to the brain's visual cortex.
So the world to them looks like this. They're blind in the left side of the visual field. And they go to the doctor, and the doctor says, well, and can you see this? No. Well, can you guess whether it moves to the left or to the right? And the patient says, well, I'm blind. And the doctor says, well, guess. And the patient guesses left, right, up, down. And the patient is as surprised as the doctor, at least they were at first. And the point is that these patients, and there's now a quite substantial number of them throughout the world, they do not have conscious access to information in their blind hemisphere, yet if forced to respond, it turns out that something in their brain has information because they can correctly guess, for example, the direction of motion. They can correctly, roughly point at a bright light. They can roughly say something about what colors is out there. No, it's very crude.
Senior research fellow Jochen Braun designed these blind sight experiments.
So let me show you the image one eye will see first. Okay, that's what it looks like. You have a background of squiggles all aligned.
Yes.
And there's this little area where the squiggles,
they're different.
They point at a right angle. Yeah? So I'll be asking you, where is this area, this different area?
It sounds easy, but during the experiment, the only thing I'm conscious of is a uniform pattern. Even though my left eye sees this, and my right eye sees this, my brain superimposes them. The theory is that some part of my brain will still know how to find the target, even though I'm not aware of it.
Now, the reason we do this is that the primary visual cortex, the first level of the brain which receives information from the eyes, receives information from left and right eyes separately. So at this level, the brain can still figure out where the figure is.
Because it hasn't been superimposed.
It hasn't been superimposed, but at the next level in the brain, it's superimposed. So at that level, the brain is blind to where this figure is.
The glasses make sure that each of my eyes will see independently. Okay, here we go. I feel a bit foolish. I can't see any variation in the pattern. It seems impossible to find the target.
When we designed this experiment, we didn't know what would happen. And then the student who did the experiment came back and said, this is very strange. I'm rather good at finding the square, but I don't see it. So then it dawned upon us that this information which does make it to the brain, at least at the first level, you can still use it, but you're not aware of it.
The results haven't been consistent, but Aaron Rosen is one of the students who can sometimes locate the target 70% of the time, even though he's not conscious of it.
The theory, which has been advanced by others, not only by us, is that there are actually two visual systems, one ventral and one dorsal visual system with different functions. So the function of the ventral visual system would be to recognize things, to read, to see faces, to acquire visual memories, and so forth. And that visual system, the theory goes, contributes to your conscious experience. The other visual system, the dorsal one, has a different function, namely to guide your movements, your eye movements, and also your hand movements, or just locomotion if you're walking around.
Or say reaching for a cup of coffee.
Exactly.
Or a glass of beer. Here's another way of looking at the two kinds of vision, conscious and unconscious. No matter how you view this glass of beer, you know it's a glass of beer.
Over to the side.
But to pick it up and move it around, a separate visual system kicks in.
In some sense, we have within us a kind of robot that allows us to interact with the world that is controlled to some degree by our conscious visual experience. So our conscious visual experience marks this as a goal object, and then we bring to bear a robot that allows us to reach out and pick this up. Different computational demands.
So in a sense, that's unconscious vision.
It's unconscious vision, and it can, in some real sense, never be conscious. It's quite inaccessible to conscious report.